All right, good morning, students. In this video, I'm going to be teaching you how you can solve this experiment E6. This experiment, the aim is to determine the potential difference across a resistor, and you can see the sectors already. I've gotten the readings. I used 1.5 volts as my EM wave of the cell. If you watch on your questions, you see where they say measure the EM wave. So here I am using 1.5 as my EM wave. So please don't use this my 1.5. You can use your own. Make sure you perform this experiment with your group. Perform this experiment with your group. This is acting as a guide. Okay, use this guide and then you score 30 over 30. All right, when the resistor R in ohm is 0.0, you see what I got. So after plotting this graph, you must definitely have your slope to be approximately this EM wave. The slope represents this EM wave, 1.5, or anything that you use as your EM wave of the cell. If your readings are correct, you must definitely get this, okay? So look at this reading. I want us to go straight to the point. I used my EM wave to be 1.5. I measured it, and this is what I have. And this reading here is accurate. So please don't use it. Use your own reading. Now look at this one also. I have EM wave. I'm using 2.2 volts here. So I can equally get the reading without performing the experiment. Yes, it is possible. Like here, if I want to feel my eye when the resistor is 0, this point is supposed to be 2.7. I'm going to have 2.70. Okay? That's exactly what I'm going to be having. We have it to be 2.7 watts, 70. When I use this 2.2. And this one is going to give me 1.40. Okay? 1.40. This is what I will have. The second one will give me 0.90 if I'm using manipulation. Third one will give me 0.70. Fourth one will give me 0.50. Fifth one will give me 0.40. And lastly, I will have 0.30. So I'm going to teach you the experiment. I'll teach you how to get the readings without performing the experiment. If you're interested, you come to my tutorial classes. The class will start any moment from now. I'm talking about the revision classes that will begin any moment from now. If you want to join us, locate my venue and join us any moment from now. If you want to know how to perform this experiment without, just get the readings without performing the experiment, I will teach you that. But that is not what I'm going to be discussing on this platform. So here, if I want to get this one is 0.3703, 0.7142. This one will give me 1.111. Okay. This one will give me 1.4285. 1 over this will give me 2.00000. This will give me 2.5000. And lastly, this will give me 3.3333. Why this one is in 4 decimal places? Remember, this is calculated value. So it is supposed to be in how many decimal places? Everything here is 4 decimal places. Okay? Then experimental value is 2 decimal places. So in this video, you see how we can get these readings. I can possibly teach you this. Don't forget to join our revision class. It will start any moment from now. All right, I would like us to go straight to the point. I will use Dick's reading. Let me use Dick's one where the EMF is 1.5 volts and plot my graph. The first question, look at our question here. First question says that we should plot a graph of R. It says plot a graph of R against I inverse. So the first question says we should plot a graph of what? Look at it. It says plot a graph of R against I inverse. So when you're starting both axes from the origin, when you plot this graph, this is what you get. This graph will definitely look like this, okay? This is my what? My R in ohms. And this is my I inverse. Okay? This graph must pass like this. It must have a negative intercept. If it did not pass like this, it means that you are wrong. This is how the graph will look like. The graph of arrow against I inverse. And look at this. I have done the graph already. So look at this graph. I've done the graph already. I've plotted the graph. So look at the graph. I've done the graph already. I've plotted the graph. You can see the graph here. You can see the graph. Look at the graph. This is exactly how the graph will look like. You see, what I have here is that the intercept here is negative. It passes from this negative. This is it. So my scale here is that 2 centimeters represent 1 unit on arrow axis. And also 2 centimeters represent 1 unit on I inverse axis. So this is how the graph will look like. This graph is very simple. If you plot it, you can see this is my slope. Okay. Now look at this. From this my reading. First thing says when it is 0.0, when arrow is 0.0, when R is 0.0, I inverse is what? 1.28. So here, this is what I have, 1.28. Then when you take this, you can trace it from the graph. Okay? You have this point at 0.0. And here is 1 point what? If here is 1, here is 2, here is 3, 4, 5, 6. Then you could have this point to be equal to 1.2. So, but basically, I just want to show you how the graph will look like. This is how the graph will look like. It must pass from here. It must pass from this negative, it must have a negative intercept. If it's not like this, you are wrong. Okay? This is how it will look like. For the first one, I plugged it. Now, if I want to use the second reading, this is the second graph for the second reading. You see, the two graphs looks alike. This is the second graph for the second reading. Though this one is here. You see the intercept here. And this is how it is. So I can use my manipulation and get my readings. Then from there, we get as many as possible. Okay, let's solve some questions here briefly. Okay, look at the next question. The next question says, determine the slope of the graph. Determine the slope of the graph. Determine the slope x and the intercept c on the vertical axis. So for me to solve for the slope, I will just say solution. Okay. I will say solution. I will say solution. The slope. The slope. The slope. The slope is equal to change in R in ohms all over what? Change in I inverse. This is what I will have, which will give me that the slope is equal to 6.2 minus 1.0 divided by 5.5 minus 2.0, which is equal to 5.2 divided by 3.5. So you find out that the slope will give me 1.48. So here, the slope is equal to 1.48, which is the same thing as 1.5. So if you can remember what I said before, I said that if your readings and your graph is correct, your slope must represent the value of your what? Your E. Must represent that value of the EM wave of the cell. Look at, I got 1.5 now as my slope, and check my readings. If you look at this reading, you find out that here is 1.5 volts. This is the EM wave of the cell, which is equal to 1.5 volts. And then if here is 1.5 volts, you see what I'm having here. So this thing represents my slope. I must get any value that is very close to this 1.5. Anything I have as my EM wave, the slope of the graph should be very close to this. Okay? Like you can see, I have my slope as 1.5. But if I want to use this particular reading now, where my EM wave is 2.2 volts, my slope should be also very close to this 2.2 volts. Okay? Anything that is close to this is correct. I can have 2.1. I can equally have 2.2 exactly. So this is it. I can use this and I plot my graph. Okay? Now, let's look at this graph and how we got this slope. Look at the graph. This point is what? Look at this graph. Look at the graph. This is 6.0. Here is 6.0. Here is what? 6.1, 6.2. So that's exactly how we got this 6.2 minus. This point, if you trace it from here, you have this to be 1.0. Okay? So this is 6.2 minus 1.0. You can see it here. Trace it very well. You have it 1.0. Then divided by 5.5. This 5.5, look at it here. 5.1, 0.2, 0.3, 0.4, 0.5. 5.5 minus 2.0. Then we got the slope as 1.5. So if I now want to get the intercept, because the slope x is now equal to 1.5. So the intercept C is equal to, check it from the graph. You can see here is 1.0. So this point here is 1. What? This is 1.9 before you get 2.0. So the intercept C is minus 1.9. The intercept is minus 1.9. Okay? The intercept is minus 1.9. And the units, if you look at this, you can see that the unit here is ohm. Okay? So you put the ohms here. That is the intercept of the graph. That is the intercept of the graph. If you look at this very well, although they did not ask us to find the internal resistance, I just want to let you know that this intercept represents the internal resistance. When you compare it with the standard equation, you have that the internal resistance is equal to 1.9 if your EMF is exactly 1.5, okay? So this is how we can solve this. This is how we can solve this. And look at this one. If I want to use this graph and solve, if I want to use this, I'm going to have my slope to be 2 point something. I will have it to be 2 point what? I will have this to be 2 point something because my E here, I use 2.2 volts. So in this graph, so the next question here Let's go to the next question. It says question number 3. Check, this is on question 3. Question 6. A parallel combination of 3 ohm and 6 ohm and the 6 ohm resistor and 6 ohm resistors is connected in series with a resistor of 5 ohm and a battery of internal resistance 1 ohm. Calculate the effective what? Resistance. So if I want to solve this, watch, this thing is a diagram. This is the diagram that you will draw for you to solve this correctly on question number 3. This is a diagram. So master 8, try to go through this diagram. These are the two resistors, 3 ohm and 6 ohm that is connected in parallel. Okay? So I will start by saying my arrow 1, let my arrow 1 be equal to 3 ohm, and then arrow 2 is equal to what? 6 ohm, and then arrow 3 is equal to 5 ohm. So this is my arrow 1, 3 ohm. This is my arrow 2, 6 ohm. And this is my arrow 3, which is 5 ohm. Okay? Now, I need to resolve these two resistors that are in parallel first. So let the effective resistors of parallel connection be R4. So I can say let the effective resistance of parallel connection be what? R4. So I can say let the effective resistance of parallel connection be R4. So I need to get this R4 by resolving these two resistors that are in parallel, okay? That is what I will do. Now, this tells me that I will use this formula that my R4 is now equal to what? R1 multiplied by R2 all over R1 plus R2, which is equal to 3 multiplied by 6 divided by 3 plus what? 6, which is now equal to 18 divided by 9. So this means that my R4 is now equal to what? 2 ohm. So this means that my R4 is equal to 2 ohms. So you can see I have gotten, we have R4 now to be equal to 2 ohms. This R4 here represents the effective resistance between these two resistors that are in parallel. And after getting the effective resistance, I will connect them in series with these 5 ohms now. That's what I will do next. So I've gotten my R4, which is the effective resistance between R1 and R2. So we cannot do the necessary connection. We can say therefore, R4, I can say therefore, R4 and the what? And R3 are now connected in series. Are now connected in what? In series. So it therefore simply means that the effective resistance, which is what we are looking for now, becomes R3 plus R4, which will give me what? 5 plus 2. So the final answer is equal to 7 ohms. Okay? The final answer is going to be equal to 7 what? 7 ohms. So this is the correct solution of solvents for question number 3. This is the final answer for question number 3. It's 7 ohms. This is the correct answer. Okay? This is how you can solve that number 3. I want you to go through this question, copy it, and then you thank me later. Okay? Go through this question. Look at it. This is a solving. Question number 3. On your workbook, check it very well. On your manual, a parallel combination of 3 ohms and 3 ohms resistors is connected in series with a resistor of 5 ohm and a battery of internal resistance 1 ohm. Okay? So this is how we can calculate this. Okay? My final answer is what? It's 7 ohm. This is the final answer. We'd like you to join us in our revision classes that is coming up from next week. We are looking at only 30 students because of our capacity. Okay, so if you want to join us, you can chat us on WhatsApp. All right, look at the last question, which is number 4. The question says an electric bed takes a current of 0.2 from a battery of 2 dry cells connected in series. Each cell has an EMF of 1.5 volts and an internal resistance of 1.0 ohm. Okay, so the question says we should calculate. First question here says that we should calculate the resistance of the cell. We should calculate the resistance of the cell. Okay, we should calculate the resistance of the cell, which is possibly asking us to find this our R, this resistance R here. So this is the circuit diagram. I've done that. You can take your time and study this, or use your pen and copy it, okay? Then we start. Look at the formula I will use. Going to apply the formula using the formula. The formula we use is that I is equal to E all over R plus R. This is my EM wave of the cell, external resistance, and the internal resistance. So I have that my E is equal to E1 plus E2. The reason is because these two cells are connected in in series. So since they are connected in what? In series. Since they are connected in series. Since they are connected in series, okay? You use this. And don't forget that each of the cell, the EM wave is 1.5. So it is 1.5 volt plus 1.5 volts, which will give me 3.0 volts. I'm going to have this to be 3.0 volts, okay? That is that. I've gotten my E. I've gotten this. And now for me to get my R, which is the internal resistance. Remember that the two cells are connected in series. So this is R1 plus R2, which is now equal to 1 ohm plus 1 ohm. This will give us what? 2 ohm. This will give us 2 ohm, okay? This will give us 2 ohm. And don't forget that the current I that is passing across is giving us 0.2 amp. So we have all these parameters. We have all these parameters. And because we have all these parameters, you can now solve for the external resistance. Okay? So we move. I'm going to use this formula that I is equal to E over R plus R, which we tell me that 0.2 is now equal to what? My E is what? Is 3 volts divided by R plus what? Divided by R plus 2. Because the internal resistance here is equal to 2. This is 2. So when you cross multiply When you cross multiply, you have that 0.2 is multiplying arrow plus 2, which is equal to 3. So this times this will give me 0.2r plus, this is 0.4. So use this and multiply 2, which is equal to 3. So 0.2r is equal to 3 minus 0.4. 0.2r will give us 2.6. And if you make r subject formula, you have that arrow x 2.6 divided by 0.2, which will give me 13 ohm. Which will give me 13 ohm. So the value of r is equal to what? It's going to give me 13 ohm. And that is the final answer, okay? So I want you to follow this. Say how I solved this. Follow it and you thank me later. Follow this method and then you see exactly what I solved. And then you do what? You thank me later. Let me allow you to copy this. Okay? Copy this. This is what I have. Okay? I want you to copy this. Copy this. Try to study this. Okay. The question is already on your manual. Go to your manual. Question number 4 is exactly what I'm solving. Copy it. All right. Let's solve the second question, which says that what amount of current will be delivered to the bell? Take if the circuits were arranged in parallel. So if the circuits were arranged in parallel, we are going to have another diagram. That is, I'm taking it to be II. If the circuits were arranged in parallel, we have that this is the first cell. Okay. This is the first cell. Connecting it in parallel with another cell, we have this. Let's do this. This one is my E1 and this one is my E2. So these two cells are now connected in parallel. I have this as the resistor R. This is what I will do. This is the second diagram. This is the circuit diagram, okay? You can capture this. This is a circuit diagram, okay? So this is the circuit diagram. Now if you get this, we're going to use another formula to solve this. Now, using the formula, that I is equal to E all over R plus R. So in this case, we have that E is equal to E1, which is equal to E2, which is equal to E3. This is just because, which is now equal to 1.5 volts. The reason is because the circuits are connected in what? In parallel. When two cells are connected in parallel, the effective EMF is equal to one of the individual EMF, which is 1.5. So I'm going to use 1.5 as my E here. And then I need to get the internal resistance by saying 1 over R is equal to 1 over R1 plus 1 over R2. This is what we have. R1, this is R2. So that is what I have. So this will now give me that my R is now equal to, or 1 over this is 1 over 1 plus 1 over 1. So this will tell me that if you solve this, you have that your R is equal to 1 over 2, which will give me 0. What? 5. Okay? So this is my internal resistance. Then I now apply the formula I to find the current delivered, which is equal to E all over R plus R, which will give me 1.5 divided by what? Divided by 13 plus 0.5 plus 0.5, which will tell me that my I is now equal to 1.5 divided by 13.5. So everything will give me 0.11 amps. That is the final answer, okay? So I want you to go through this, and then this is the solution to the question II of that question number 4. This is the solution. So I want you to copy it. This is the current that will be delivered. Go through this. I want you to copy it. Okay? So you can say we have solved this one. We have solved this one. The resistance is 13 ohms. And this one is for the II, the current that is delivered. All right, I would like you to also, the question says, what are the precautions? There are some precautions we normally take. You can write that tight connections we are made. I ensure tight connections we are made. There are as many as possible precautions you can take. So you can write the ones you know, and then score 30 over 30. You thank me later. So finally, I've solved everything, and I want you to know that the White Faraday is going to start his revision classes any moment from now, and I'm collecting only 10,000 for Maths 102, Physics 102, Practical. I will start from Practical. I'm going to be teaching you how to get readings without performing the experiments. I will teach you Practical Physics 108, Practical Chem 108. I'm going to start it any moment from next week. So if you want to join the revision class, you can chat me on 070 36 22 1432. I come again, 070 36 22 1432. Thank you, and God bless each and every one of you. I love you guys.